Section 7.5 in college algebra. Solving systems again, just not linear systems every time. You can see the first guy, quadratic, because the biggest exponent is the 2. This guy is linear, and we have to solve them how they tell us to solve them. The cool thing is, at least we have a graphing calculator to check to see if our answer's right if you wanted to graph them both. But of course, to graph them both, wouldn't you have to get y all by itself on each one of these, you know? But let's use substitution to solve this system. Your choice of what to do. I feel the easiest one is we've got to get a variable all by itself on one side of the equal sign in one of these equations. It'd be pretty easy to get a variable all by itself in that equation, correct? You could solve for x if you wanted to. You could solve for y if you wanted to. I will look to the other equation to see what would probably be easier. In my opinion, it would be easier to get y all by itself, because then wouldn't we just have to substitute one thing in for y? If you solve for x, then you got to substitute all this stuff in for x, and then you got to square it, and then you got to do this, and you probably get a binomial, and you got to square a binomial. It's like, let's solve this bad boy for y right here. So let's do that. This would be negative y equals negative x minus 4. Watch that sign, correct? And then, of course, divide everything by negative 1. Y equals x plus 4. Are you cool with that? That means we can take this, x plus 4, and substitute it in for y into the top equation, because that's what y equals. So I would have x squared minus x minus 3, and where there's a y, you should put parentheses around him, because x plus 4 should go in for y is in parentheses, and that's equal to 0. Cool with what I've done so far. I will clean this up a little bit. This is x squared minus x minus 3x minus 12 equals 0. Correct? These are like terms. X squared minus 4x minus 12 equals 0. And now you have this quadratic equation that you need to solve. Quite honestly, if it doesn't tell you how to solve it, you can solve it any which way you want. If you want to use the quadratic formula, do it. I would check to see if this is factorable, though, and your guys' factoring is better than it has been in the past. Since the a value is 1, remember the number in front of x squared, can you find two numbers that multiply together to be negative 12 and add together to be a negative 4? Well, if you make a list of multiples of 12, first you should realize that one of the numbers has to be negative, correct, since they multiply together to be a negative. So it's either these two combinations, which that doesn't work, because that's either 11 or negative 11 when they add up to. Then you go with 2 and 6, but one of them has to be negative. And isn't this your winning combination right there, that a positive 2 and a negative 6 work out? So since this is easily factorable, it's x plus 2 times as a quantity, x minus 6 as a quantity, and it's still equal to 0. Questions on how I factored that? You don't have to do all that frowny face factoring, is what I've always called it, because the a value is 1. When the a value is something other than 1, then you got to go through all that work, which we'll do some other day. Now you use what's called the zero product property. You got a green guy times a red guy, because you always take a blind eye to what's in the parentheses. It's just a green thing times a red thing multiplied together to equal 0. Shouldn't it be true that one of those things would have to be 0 for that to be a true statement? Like if the green thing was 0, 0 times whatever the red thing is, shouldn't that turn out to be 0? Well, what value of x would make the green thing turn out to be 0 if x was how much? Negative 2. It could have been possible that the red thing could have been 0 also. What value of x would make the red thing 0? Either one of those two situations would be a true statement. What you could have done also is graph this blue thing, and that's where it crosses the x-axis, but unfortunately, they want you to do the algebra. So now we're trying to find the two ordered pairs, so we have to substitute back in, and we've got two different situations. Why don't we set up our two ordered pairs? First off, this is what it's telling us. I know the x values. In one of those ordered pairs where they intersect, x was negative 2, and in the other ordered pair, x was 6, right? So here's my two answers right here. Let's put negative 2 back in. Where would I put it back into? Probably the box. Wouldn't that be a pretty simple situation to see what y would be? This is so simple that you don't have to show me any work. You know, when you're substituting back in for y, I mean, this is as easy as it gets. Negative 2 plus 4, how much? 2. And that was when x was negative 2, though, correct? So that's why it went for this y value. What about if x was 6? What would y turn out to be? And these are our two answers. This is what, if you graph this top guy and you graph this bottom guy, it would be a parabola and a line. That line would cross that parabola at those two particular points. Woo! Next, use substitution to solve for this. We know what y is equal to already in this one, so why don't we take this and substitute him in for y? Is there any coefficient in front of the y at all besides 1? So I really don't even need to worry about putting parentheses. I'm going to say that this is 2x, and then that entire box comes down. All of that stuff goes in for y, and that is equal to 4. Cool with my substituting. Since y was already by itself in one of those equations, I just put them in there. Now, these guys, it is quadratic because you got x squared and x is to the first, but since these are like terms on the same side, what does 2x and a negative 2x add up to be? Nothing. So you got negative x squared plus 8 equals 4. Right, these cancel each other out, right? They added up to be nothing, right? Subtract 8 to both sides. Because x squared is all by itself, or sorry, there's no x to the first, you only have x squared. Let's get x squared all by itself. Divide by negative 1, x squared equals 4. And now since it's only x squared, no x to the first, how do you get rid of the square? You square root. So you got to be very careful. What's the square root of 4? Plus or minus 2. There are two different answers to that. X could be 2, or x could be negative 2. So again, set yourself up two ordered pairs. In one of them, x is 2, and in the other one, x is a negative 2. And now I'll substitute back in. I would probably go into this guy right here, to be quite honest with you. It's much easier. If I put 2 in for x, I would get, I'll just do the work right below this or whatever, 4 plus y equals 4. And I put 2 in for x right here. Right? Subtract 4 from both sides, y equaled 0. Not negative 0, that just says 0. Now put negative 2 in. That would be negative 4 plus y equals 4, and y could equal 8. So these are my two answers. I solved that system. That parabola and that line intersect in two places. Cool with those? Yeah. How do they want you to solve this one? Graphically. Let's graph both of those. Before I even try to zoom 6 it or anything like that, you should think before you graph. This is a cubic, correct? Which looks like a snake. Something like this, correct? This is a parabola. Can you tell me if this parabola should open up or open down? You're looking at that. Should he open up or open down? Should open down. So I should see something to the sorts when I graph that. Let's zoom 6 and see what happens. There's your snake. There's your parabola that opened down. Difficult to see. First of all, can you see there's two places right there where they intersect? That's all we're doing, is looking to see where they intersect. The question is, do you think that this parabola intersects this snake way down here also? What do you think? Doesn't this, let me make a little sketch for you. Here's all you see. There's the snake, and there's the parabola. But doesn't this parabola go on forever? And doesn't this snake go on forever? Shouldn't they eventually cross down there somewhere also? So first, let's find the two easy ones while they're on our window. Second, calculate. We want to find an intersection. So the first curve, the second curve, you can just hit enter. Then you got to guess. You got to put your cursor close to somewhere. where you feel that is. So see my cursor? It's in the neighborhood, I guess. 4, 0. All right, so there's 1, 4, 0. Now I'll do that again. Second, calculate, intersection, first curve, enter, second curve, enter. Guess I have to move my cursor closer to that other place of intersection. I'll bet it's at 6, 0. 6, 0. But now the fun part. We've got to find that third place. We definitely have to change our y minimum. Change it to a negative 1,000 is what I would recommend. Just because I've done this and it's way down there. So that y minimum, negative 1,000, I will go by hundreds on that scale also. And let's see if we can see it. We've already found those two up there. Who cares? There's that third one right there. So if you second calculate him, he was at, I'll let you find it for me, negative 6. Yeah, that's what I got. Negative 6, negative 720. And that's a trial and error thing. You know, the hard part is understanding that there should have been a third point in the first place. It's like, because you didn't see it, you have to understand your graph from the Zoom 6. It's like, oh yeah, dude, that dude goes down forever, and this guy, they're probably going to cross paths somewhere. Cool? Pretty simple. Next one, read it. So we read it, and then I highlighted some very important information. Some people don't read below that for some reason. They don't think that's part of the problem. It literally tells you what to do. It says market equilibrium is when the supply price equals the demand price. So this green thing should equal that blue thing, correct? They both are solved for P. Why don't we just take their what P equals and set them equal to each other? Q squared plus 804 should equal 1200 minus 60Q. All in terms of Q, but you got Q to the first and Q to the second. Let's get everything equal to 0 so we could maybe factor or use the quadratic formula or something like that. So I would like to keep the coefficient in front of Q squared to be a positive one, so I'm going to bring everything over here to the left side. I will still have a Q squared, and then I will add 60Q over, and then subtract 1200. 804 minus 1200, you can punch that in, and that will equal 0. Right? I'm a pretty good factorer. A is 1. I don't want to waste my time trying to find two numbers that multiply together to be negative 396. That's too big, right? Why waste my time? I will use the quadratic formula to solve this, to where I need to know what A equals, B equals, C equals. This is up to you if you want to write this little baby stuff down. I'm a big believer in it. A is the coefficient of Q squared, B is the coefficient of Q, and C is the constant term. And now we just got to remember what the quadratic formula was. It is the opposite of B, which would be how much? Plus or minus the square root of B squared, which I usually punch that in my calculator right away. I'm taking 60 squared. You know what 6 squared is. It's 36. And there'd be two zeros involved with 60 times 60. Minus 4 times A times C, all over how much? 2 times A, which is 2. So when doing the quadratic formula, I'd like you to just punch all of this stuff in for me real quick. Just type that left to right, how you see it, 3600 minus 4. Use parentheses and you'll be in good shape. Times 1 times negative 396. And tell me what that number is, if you wouldn't mind, because I don't have it written down. How much? 5180? 84. 5184. Y'all cool with that number? That's got a special name. It starts with a D. What's that thing called? The number under the radical? That's the discriminant. If the discriminant is a positive number, you will get two answers to this. If it is a 0, you will get one answer. If it is negative, there are no real solutions. First thing I'd check to see is if that discriminant is a perfect square. I would take the square root of 5184 and see if it comes out nice. Is 5184 actually a perfect square? So you got negative 60 plus or minus, it was 72, is that right? All over 2 still. And this is the tricky part for peoples. You need to do what's in the numerator first. Negative 60 plus 72 is 12. It's still over 2. Now I'll use the minus. Negative 60 minus 72 is a negative 132, is that right? Check me on that. Negative 60 minus 72 is negative 132 over 2. So this is saying 6, right? 12 over 2 is 6, or negative 66, is that right? So now we got to interpret it. Okay, what does X stand for again, basically? It's your Q's. What's Q? The number of 100 units, right? Q is the number of 100 because we just solved for Q. Can you have 600 units? Yes or no? That makes sense. Can you have a negative 6,600 units? So this is an extraneous answer. We'll throw him out. And then the answer to this is 600 units, because it was in hundreds of units up there. Awesome. It factored, though. I could have told you, anytime this number, the discriminant, is a perfect square, that was factorable. You'd have to find the two numbers. They were 66 and negative 6. That would have taken forever to find those two numbers that multiplied together to be that and added together to be this. Quadratic formula. Final one, baby. Woohoo! Look at this. Old school advanced geometry formulas on the wall. Might want to write them down while you read this problem. This is a hard problem, I'll show. First question for you, is this a cube? Looks like it. Did you read the problem? Is it a cube? It's a box. What's a cube? The length, width, and height are all the same. They didn't tell you it's a cube, they said it's a box. So you don't know if the length, the width, and the height are all the same. An open box. Oh crap, what's that mean? That it's an open box. What's it missing? The top, right? This is an open box right here, visually. Correct? No top on it, right? An open box with a square base. Oh dear, what do you know about the base? What's a square? That's a rhombus, all sides the same. And 4 right angles, 4 equal sides is a square. Good luck on your ACT geometry portion if you don't know what a square is. It's got 4 right angles and 4 equal sides. So we know all 4 of these bad boys are the same, so that the area of the material used is 300 square centimeters. So isn't that talking about, out of these 3 things, would it be lateral area, surface area, or volume? Lateral area, only the area of the lateral faces. Surface area, lateral faces, and the base areas. That's what this says. Take your lateral area plus 2. What's the capital B stand for again? Base areas. Lowercase b stands for base. Capital B stands for base area. It says we got a square base. So do you know anything about the sides? You know something. Something. You don't know how long they are, but you know something about the sides of a square. You just mentioned it to me. What do you know? All the same. So I don't know how long it is. How about x, 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 and x? I drew that there for you. If that picture was not there, you should at least sketch a box to see what's going on. Because it's a square and all 4 sides are the same. There we go. How about the height? Do you know anything about the height of that? Is it the same as x? Should it be? When would it be the same? When the length, the width, and the height are all the same. When it's a cube. Is this a cube? So it is a different height. Let's call him y instead. They give me some stuff. They say the area of the material used is 300 centimeters squared. We discussed that is surface area, correct? Will this formula fit for this particular problem? Something's got to get modified. What's got to get modified? We don't need two base areas because this is an open box, correct? So let's do this. Surface area equals the lateral area plus one base area. And make yourself a note because it's an open box. All right, there's not two base areas to it. The top one's missing. Cool? Lateral area. Let's find him off to the side. P stands for perimeter of the base. H stands for the height. What's the perimeter of the base? X plus X plus X plus X, a.k.a. 4X times the height, which is Y. Good? So surface area, which we do know is 300. Everybody down with that? The surface area is 300. Will equal the lateral area, which we just figured out is 4xy, plus one base area. What would be the area of that base? X squared. So far, so good. Here's one formula we use. They also give me this volume of the box is 500 centimeters cubed. So I know this. I know the formula for volume is length times width times height. Correct? If I substitute in, I know the volume is 500. That should be cubed instead of squared. That's a typo. I know the volume is 500. The length is x. The width is x. And the height is y. Everybody down with that? Which can clean up to be, of course, x squared y. Whew. All we've done is figure out two equations so far, correct? What do they want to know? They want to know when they are the same, correct? An open box is to be constructed so that the area of the material used and the volume of the box is 500. What are the dimensions of the box, right? So let's solve a system using these two equations. I wouldn't want to graph it. That's nasty. If you get y all by itself, my graphing calculator would just be a giant waste of time. What I would want to do is use substitution like we did on the very first problem. To solve one of these variables, one of these equations for a variable, I would probably pick this guy. And what would you solve for? Solve for x or solve for y? Because you could do either one. You could solve for x if you want to. You could solve for y. What would be the easiest one to solve for? Y, because it's to the first power. X is to the second power. What would you need to do to get rid of this times x squared? Divide both sides by x squared. So y will equal 500 over x squared. With me? Now, I will take this and substitute it in right there. So, squiggle, 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 squiggle. 300 equals 4 times x times 500 over x squared plus x squared. All I did was where there was a y, I substituted this red blob in for him. Holy ugliness, Batman. Let's, Zoinks is right. Let's multiply. I'm turning 4x as a fraction. Let's multiply 4 times 500. 4 times 500. 2,000. There's an x up there over x squared plus x squared. All I did was multiply these two brothers together. So far, so good? Notice x is upstairs, x is downstairs. Where are there more x's, upstairs or downstairs? How many more are down there? So let's say goodbye to you and goodbye to you. There's one x downstairs when the x's upstairs went away. So far, so good? This is still ugly because there is a fraction in it. Anytime you would like to clear the fraction, let's multiply by a common denominator, the least common denominator. There's only one denominator, x. How about we take every term times x to get rid of this nasty fraction? So taking everything times x, 300x equals this times x and this divided by x, eliminate each other, and wouldn't you be left with 2,000? And finally, what is x times x squared? X cubed. Fabulous? Next, let's get him equal to 0. What would you do to get him equal to 0? I subtracted 300x from both sides, and I put it in standard form, x cubed minus 300x plus 2,000. You need to know when this equals 0. What would you do when that's a cubic to figure out when it equals 0? Hint, what would you do when you want to know when that equals 0? Starts with a G. Graph it. And when will it equal 0? When is y 0? Isn't this the y place right here? When is y 0 on a graph? If I asked you to graph y equals 0, wouldn't that be a horizontal line that goes through 0, which is called the x-axis, correct? So we want to see where this puppy crosses the x-axis at. X to the third minus 300x plus 2,000. I'll bet our Zoom 6 doesn't fit. How many places is possible for this to cross the x-axis? 3, because this is a cubic. There's 3 possibilities. It doesn't mean you're going to get all 3. Oh no, I didn't see them all. Change the window. We definitely need to change. We care about where it crosses the x-axis, correct? So we need to change our x parameters. Let's change both of them. X min, let's go to negative 100. And let's go to positive 100 by at least 10s or anything else. It doesn't really matter. You can graph it. Who cares what the y scale is at? I care about where that puppy crosses the x-axis at. I still only see one place, right? Did I type it in right? Hold on. X cubed minus 300x plus 2,000. Is that what we have? Yeah? Okay. Let's change our window again. Didn't see enough. So let's go to 500, see what happens. When I didn't change my y scale, it was scrunching stuff together too much to where I couldn't see where it crossed the x-axis at. So I did have to change my y scale. We went way down to negative 3,000 to positive 3,000. So it's not so scrunched together. And it just so happens that I see these 2 places now on the graph. You can second calculate the 0 of this puppy. Or you could guess if you wanted to. Let's do that. Doesn't it look like that's happening at 10? Remember, we're going by 10s, right? So if you trace 10, see if that's a 0. Didn't you get 10, 0 on that situation? So 10, 0 was the solution. And the other one, if these are going by 10s, that's negative 10, negative 20. If you trace negative 20, that would work also. And isn't that a situation? These are the zeros of this thing. But what are they really saying? X is like the length of this thing. Can negative 20 be a length for the bottom of your box right there? So that's extraneous. It is 10 centimeters. That's what that really is. So we had to graph it, and we had to change our window to where we'd see that cubic. And for some reason, my graph was just scrunching stuff together too much by not changing the y scale. So play with it.